It's that time. It's 1300 on the East Coast, 1800 Greenwich Mean Time, and it's some other hundred everywhere else. It's PFG Live. Good morning. Kevin, Mr. Blodgett, sir, you're first in. Therefore, it is your responsibility to give us a video and audio check. Oh, Brian jumped in on you. Good. Excellent. Well, good morning. Nice to see everybody so far. How's everybody doing? So, if you've been following, and I know you have, I've been trying some new things this past couple of weeks, and I guess that's the topic for today. We don't have any guests, but I think we're going to have some guests next week. Thank you very much. I appreciate it. Well, it's good to be here. What have you guys been up to? Carl, good morning. Thank you. I hope Silos of Silos Garage shows up. Sleeping Saloon, good morning. Welcome aboard. MS Live, good afternoon. Close enough. It's afternoon somewhere. Today it is a gray day here in New Hampshire, but still a beautiful day. Temperatures are 45 degrees, 45 Fahrenheit. We're heading for 47 today, which is really bizarre. I mean, you have to keep checking that it's the middle of January. Machine Tech, thank you very much. Oh, interesting. Did you change your... You changed some things, sir. I do have a report. And actually, I almost asked to bring you on to the live today, just for the discussion. So we may ask you to do that. So stand by. Hey, Art That Makes Art. You had a blizzard. Holy cow. Remind us where you are. Greenwood says a little on the cold, windy, and wintry side in southern Idaho. Well, kind of crazy how not cold it is today. So as you may or may not know, I have solar panels, and having snow on them is not a good idea. So I'm actually pretty happy to have a little warm weather to shed the snow that's on there. Kevin reports blue, clear, 32F in the Oregon. Nice. Kind of freezing, but maybe not. Maybe you're at the triple point. Well, that's pretty awesome. Well, the gang is getting here. I do have a report, except my data is not very orthogonal to the variables, or the variables weren't orthogonal. We'll talk about it. I am going to discuss it. Brian says 41 and rising with rain in northeast Ohio. Right? 41. And Art That Makes Art is in southern Idaho. I forget sometimes. Henry's here. Henry, you are forgiven for being late. We're just doing weather reports right now. Okay, thank you, Adam. So you changed the name of your something. It says Machine Tech Video Blog. You almost confused me, but I see your logo, so that's what made it all good. And you will be interested to hear what trials and tribulations I went through. I don't think we're going to have Robin in the chat. He specifically told me he was busy today, so we won't have him around to push us around. Maybe Ox Tools can figure out how to comment. We'll see what happens. Okay. So, yeah, much to report. Had fun in the shop this week. Oh, roger that. Old YouTube account. Okay, cool. Almost Machining is here. Good evening, no noon morn. 55 in the Valley of the Sun. So if you don't believe in global warming, hey, CJ Stevens reports he finished The Perfectionists yesterday. A wonderful listen. I'm glad you enjoyed that. I also thought that that was a fantastic a book and audiobook. I loved the audiobook. Henry says it's a bit cold in Germany. No, I'm sorry. Yeah, you're in the Netherlands. 1.5, minus 1.5 C and pitch black. That's because you're ahead of us. You're like taking point on the rotation of the Earth. MS Live reports 8 Fahrenheit and partly cloudy. Yeah, it's kind of like what it is here, except 40 degrees colder. Yeah, it's been a little weird around here. So much to talk about. As you know, we're on the lapping. We're sliding down, as I put it earlier this morning when I was talking to somebody. We're sliding down the razor blade of precision, and learning a lot. Almost reports we are well below our normal and have had boatloads of rain with more on the way. No, you are in. I'm sorry, Henry. I know you were in Germany. It's so confusing. You were vacationing. No, you vacationed in France, didn't you? All rise for the Honorable Robert Isaac, also known as Bob Labs. Welcome aboard, sir. I did a random live yesterday from the shop on Instagram, kind of like the old days. I kind of enjoyed it because I had to stand there and lap my, rub my laps together. So I can't believe we made a 54-minute random live yesterday while I was standing there rubbing my things. So we could talk about that today. I will show you some results. I will show you some pictures that you haven't seen before. Is that true? Yes, there's one photo that you haven't seen before. If you've been following Instagram, you might have seen these already. But it's been quite a lesson. We're doing natural light today because I like the light that's coming through. So we decided not to go with artificial light. So that's the way it is. So let me fill you in. I know there was already a question about square laps. So, in fact, I think I could show a picture of the square laps. Oh, thank you very much. I never got specific clearance from you on the use of your photo, but sue me. Henry. Oh, Carl. Carl just told Henry, you have a Dutch first name and a German last name, so we have a 50% chance of getting it wrong. And Henry says he's going to be in Switzerland for a week. We'd like a full report on that, please. What a riot. So let me see if I can show you a photo of the square laps. I think I might have. Oh yeah, here it is. So there's the square laps in question. So when I started the lapping journey this last couple of weeks, we started on the square laps. And the reason we started on the square laps is because I had them. I bought them on eBay. I had ground them flat. I have 2 sets. The one pictured over here is the coarse ones. It's like a 1/4-inch squares. And I also have one that has smaller squares. And they're basically from the same supplier. I've never been able to identify who it is, even though there's a maker's mark on it. And those were sitting in my drawer for a long time. So I started with those and with aluminum oxide 5 micron. And I started getting some success. And that so these were the laps that Robin finally said to me, ditch the square laps, go to the round ones, meaning the round ones that I made. And there are some geometrical reasons for going with the round laps. And after you understand more about this process, you'll understand why the round is nicer. It's not that the square doesn't work. It's that the round is better. So let me just let me queue up the slides and show you the pictures I wanted to show you. Give me a second. Yes. So we were right here. Okay. So on the square laps with the aluminum oxide, I was getting frustrated with not getting things quite flat. And let's see. I think this is when I switched to the round laps, I immediately got better results. And this is the results that I got. Thank you. Thank you, Bob Labs. Yeah, that was fun to make. Hopefully we'll have more to make as we get smarter here. So you'll notice that I took these two photos. Let's go back one. And I got the bands 90 degrees out. In fact, you could see the blemish up on the upper left corner right there, and that proves to you that this is the same part. So Robin taught me something which I thought was really useful, and I'll pass it along, which is that when you have, for example, let's say that the contact point on this, let me back up a little more. What you're looking at is you're looking at a lapped disc of A2, okay, and sitting on top of it is an optical flat. And then we illuminate it with a monochromatic light source, which in this case is a helium light source, which has a wavelength of 560-ish nanometers. And then you get this interference pattern. See previous video that I made on recently. But what Robin pointed out, and I'm going to use my cursor here, is if your contact point is at 3 o'clock in our photo, and your wedge is increasing in thickness, that's the wedge of air as you go to the left, you get these nice vertical bars. Well, that's the straightness of the bars is telling you how wonderfully flat your part is in one axis. So it's the spacing of the bars that might change that for the other axis. So what Robin taught me to do is to, oops, got ahead of myself, manipulate the flat. Yes, almost. I did swap media at the same time as the laps. So that does obfuscate my results, but we'll get to that. So Robin taught me to manipulate the optical flat to get data with the bars in two different directions, 90 degrees to each other, orthogonal to each other. And that's what we did here. So you're going to see from now on that I'm taking pairs of pictures. But the point is that as soon as we switched to diamond plus the round laps, for reasons we'll talk about, we started getting results. So I was very happy with these results. Then I switched over to working on the 1, 2, 3 blocks. And as you can see right out of the gate, the 1, 2, 3 blocks needed some work. Oh, Jeff is here. He says he's late to the party. He had to catch COVID in order to have time to join in on the live. Oh, Jeff, heal fast, man. Chicken soup. So this picture shows the start of these 1, 2, 3 blocks. Now I have the blocks right here, by the way. And even on the video, look at that. So you could see grinding marks from the apprentice grinding hand who made these. And these are actually have enough texture to prevent getting any information off the optical flat. So, I tested it. So this picture is after initial lapping, and we can see that we had a ways to go. This is with a smaller optical flat, but this is on the round lap, the round lap and diamond. So we're doing 3 micron diamond. So we started working on the 1, 2, 3 blocks, and they started coming in. Now take a look at the shape of these curves. Clearly, the contact point in this case is on the left, so clearly this guy is convex, and the curve is pretty smooth. You see that? Now here's something I learned this week. If I show you the next picture, your initial reaction might be, hey, it's getting straighter, it's getting better. Well, let's look at this shape. It's kind of straight in the middle, and then as you get to the edges, it curves. Straight in the middle, curves. So what this is, and it's incomplete lapping. It's like you have these hills, and you started lapping, and the hills got a little flatter, but you haven't finished yet. So that's what this picture is. Plus, you could see a little defect around some corrosion on that block. That was interesting. And then we did a little more, and we started getting pretty decent results. Again, this isn't finished, but this is starting to look better. Okay? And I started getting better, but I couldn't bring it in for a landing, and this was driving me nuts. So, again, improvements, but it's not there yet. And then I had an epiphany. Let's see if I get to the epiphany slide here. Oh yeah, let's go back here. This is the picture trying to get some fringes off of the as ground surface. Was not happening. Okay. Oh, let me show you something very interesting. So here's an as ground surface, right? Focus, please. Focus. There we go. Okay. And if you take your PFG stones, and I'm going to use the brown side, the coarse side, condition my stones. Okay. I'm sorry. The ASMR guys like this. Okay. We condition our stones, and I stone that face. It immediately tells us what's going on, right? What does it tell us? It says, come on. It says, hey, boss, you're contacting on the edge of these grinding lines. Okay. You see that? So if I wipe my finger across here, you'll see it takes away the nice black schmutz, which is the indicator of where it was hitting. So the PFG stones are a tool that says, hey, you're hitting on these high spots, on these ridges. So that was the lesson learned there, is that you're not going to get any sort of indication off of an optical flat doing it that way. And then I had this epiphany, and I started getting results like, hang on, I got to get to my, like that. Look at that. Okay. And there's your 90 degrees. Now, I was so happy. And I am now going to tell you what I did to achieve that result. So, here's my flat. I'm going to use a PFG stone as an analog to my part. So I took that. Let's move over. I took that 1-2-3 block, and I had been working the 1-2-3 block like that, right? And I was not getting flat. I said, why don't I start working it around the edges? And this is where Adam his ears should be perking up. I'll work it around the edges and let the part hang off the edge, just like in the process of figuring the two laps against each other to intentionally get that curve, or like Adam making his a telescope mirror, right? And you're figuring the top one so that it becomes concave. Okay, that's what I did with my part. I ran around the edge and I kind of visualized a circle inside my part, and I tried to put that circle tangent to the circle of the lap as I was going around. So what did it do is it was forcing concavity. It was forcing concavity on my part, which is this 1-2-3 block. Look at the result, okay? This is how I got these lines. Hey, K-Bonk. You're working on getting flatosity on your cast iron skillet. Listen, dude, if you need somebody to help test the results, I will come and test the results. My wife made for me these 3 fried eggs on avocado and homemade bread this morning. Oh, good investment in a skillet. So let's go back. Okay, I was here. All right. I was here before I got the brainstorm of treating the workpiece like it was bigger and hanging off the edge of the lap. And then I got there. I was so happy, I cannot tell you. So for me, this was the epiphany of you actually have the ability to start controlling the curvature by, in this case, it was technique. It was just that overhang. That was the only difference. So I do believe that my cast iron lap is, so let me put it this way. I think I got this from a lap which was flat. In other words, I don't think my laps are convex. I think they're flat, and I was getting non-flatness on my part. And my theory, my working theory, was that it was either technique or it was getting more abrasive action at the toes of the work and not at the center of the work. But by changing my technique with overlapping off the edge of the lap, I brought it in for a landing. So that was the huge thing this week. And I thought that was a great lesson. So the reason, so let's back up a little bit. The reason that Robin said, go to the round laps is because when you figure the conditioning lap, which is another word for the top lap on the bottom lap, you're intentionally making the top lap concave and the bottom lap convex. That will happen automatically. And you do that in order to have control. I'm going to say something that is going to be controversial. You need a convex lap to lap flat. Okay? And I think it has something to do with how the abrasive particles work under the flat. That's kind of what I'm observing. And then you can control how convex it is with the conditioning lap. So here's something that I figured out also, is that if you have these two identical laps and then you flip them over and then you condition upside down, you start taking the convexity that you built into your lap and you start reversing it. So you can control, you can go back and say, oh, I need less convexity, flip your laps over, condition it, flip them back, put the top one aside and keep on going, and you've just changed the bottom lap, which I think is pretty cool. If you guys have questions or comments or snide remarks, please put it into... No, I'm not a freaking genius. Adam, tell me, am I figuring things out that everybody else already knows? Or did I just give an explanation to something that you've been wondering about? Seriously, I need to know this, because I have no idea if what I've concluded is based on good information or bad. But I think you get it, Adam. I think you understand that you can by inverting the conditioning lap and the working lap, you can start reversing that curve. So now you have control of it. It's like you have your hand on a knob, and you could figure out how much you need. So here's the rest of the story. The rest of the story, let's see. Almost Machining says edge lift and grit migration, also pulling new grit up from the grooves. They have a dual-edged diamond sword in this case. Always use the whole surface. Yeah. There's processes going on in there that I haven't figured out yet. But we're getting there. We're getting closer. Somebody else in the random live yesterday on Instagram said, hey, I have a Blooky Dookus machine. I can't remember the name of it, which was a little lapping machine. And he said something about getting one. And I'm like, yeah, that's a whole other rabbit hole that involves machines and square feet in the shop and stuff. So I think I'm putting a limit on my lapping projects to manual lapping only. Okay, I don't think I'm going to go down the mechanized rabbit hole. So after my epiphany and after getting these straight lines and feeling so good about myself, I said, oh, I want to go to 1 micron now. There was only one problem. I didn't have a pair of laps ready to go. I only had one more of my round laps. So what do you think I did while I read the chat here? Bart asks, what depth did I make the grooves, and does it matter? I want to make some myself. To be honest, I don't have a number for you. I would say that it is approximately, and I'm going to give it to you in imperial units, it's on the order of 20 thousandths deep-ish. So, does it matter? It does, but it matters in the fifth term of some polynomial equation, which I don't understand. So I didn't make it to a certain number for a certain reason. Okay. So Adam says hand lapping on a flat lap always generates a convex surface because the edges of the part wear faster than the center due to the tribology involved and the changing force vector during motion. So let me see if I could decode that a little bit. the tribology is the lubrication of the medium. So you're confirming to me that the edges of a part always wear faster. So that's why you need your lap to not be flat. Your lap needs to be convex to achieve flat, which is what I'm starting to understand. So that jives. And then Adam says, hence Robin's convex lap concept, which we talked about, and my method of hanging off the part, or actually hanging the part off the lap, is great. Thank you. The fact that you had this control was pretty amazing, and I'm going to use my graphics system here to illustrate what we're talking about, because a picture is worth 1,000 words, and who could stand 1,000 of these words? So this is what's in my head, which is scary enough. Right, here's your lap, and your lap is convex. Okay, and then here's your part. We're doing it live, folks. Here's your part. So my claim is that, and what Adam is also saying, is that you get more abrasive action here, okay, and here, because you're capturing, I guess that's not what I'm saying. What am I saying? I'm saying that there's two things going on, is what I'm saying. But you need this shape in order to achieve flatness on that part. Because otherwise, you're making room. You're making room for the particles. That's what you're doing. You're making room for the particles here, so that they do not abrade as much as the particles that get caught here. That was well said, Adam. So Paul says, so you are pairing your laps per grit size due to contamination, as well as always conditioning them together. Yes and yes. Absolutely. The laps have to live together, because the top lap and bottom lap, or conditioning lap and working lap, have to match. And they're married forever. Period, full stop. Which is part of the funny thing I'm about to tell you. And Adam says there are many ways to do a thing. This way works for you, and now we'll adopt the bits that work for us. That's beautiful. Yeah, I'm not saying I have this thing locked down and I understand it, because I don't, which is what makes it interesting. But I'm just reporting what I learned by observation. So after I thought I was brilliant, I made a change to the process, and I got that. This is not an improvement. So I did not observe. So Bart suggests that there may be a temperature influence. Handheld part on the outside will make the outside warmer and expand more than the inside. I would suggest that the temperature part of it, I don't know. I don't think it was a player here. However, you do have a point, and that could be proven with a thermal insulator, like a piece of foam between your hand and the part. So that's worth testing. A handle with a ball and socket and a suction cup to hold the part. Yeah, absolutely. That's another way to. So I thought about actually I thought about that for the, where are they? Right there. The 1, 2, 3 blogs have a hole in them. And at one point I was taking my reinforced finger. This is reinforced finger in the hole, reasoning that I was going to be pushing down the center of the part and that would be healthy. I don't think that made a huge difference during my observations, but that was absolutely something I was thinking about. So I like your idea of a suction cup. I didn't think of a suction cup because I already had the hole there, but I like the idea of the suction cup. So I ended up with screwing up the part. So let me tell you how I screwed up the part. And you will say, aha, it's sort of logical. I took my number 3 round lap, which was a virgin, and I charged it with 1 micron. I shouldn't say I charged it. I dumped 1 micron slurry, like this, okay, except that's 3, on top of the lap, and I just started going at it. Okay, so this is an unconditioned lap, doesn't have a partner conditioning lap, and I just went at it. And look what I got, just like instantly. This was, not even 5 minutes. And I turned it back into a mess. So I'm getting pretty convinced about some of these things. Now, my plan is now to take this block and go back to my conditioned, well-tempered pair of laps and bring it back. And actually, Robin said something to me in one of our conversations which I will paraphrase. He basically said, you should make it flat, then make it unflat, then make it flat, then make it unflat, getting the control. And I forget exactly how he put it, but this is a good idea. When we used to teach people spin recovery in gliders, one of the things that we would do is fly a circle right on the edge of the stall speed of the glider, which is not too far from how you thermal a glider. And then you would intentionally kick it into a spin with the rudder and then kick it out of the spin, do the recovery, and then put it in to the spin entry and then kick it out to a spin recovery. And then just play that edge, and that took away, in the flying world, that took away the fear of like falling into a spin. It's like, no, you're under control. Adam says a 3D printed holder which contacts the back of the part only at the 3 points of minimum sag, like a service plate, and which also reduces transfer of thermal energy. Yes, actually, I had a different idea, which was similar to what you're saying, but my idea was a 3D printed thing which had a hole that was a little bigger than the part, and it had a little ball in the middle. So you were still pushing on the center of the part. You're suggesting pushing on the minimum sag points, okay? But the outer part would just locate, just give you a way to push on the part and not influence it much, and make a 3D printed thing. I think that's a great idea. I think your idea with the calculating the minimum sag points could be also brilliant. So I like that. So yeah, 3D printed tool in order to get the job done. I think that'd be great. Okay, pretty exciting. So this is when I said yesterday that I achieved epiphany and I made the flat part and then I screwed it up. This is how I screwed it up. So my goal is to bring it back and understand how I did it. And it is in the understanding that I'm hoping to figure things out. When I put out a call for books, one of our guys gave me a recommendation for a book called Fabrication Methods for Precision Optics by Carow, K-A-R-O-W. I found it. It's not cheap. It's going to be a $90 book, but I might buy it. So Paul says, my variation of Robin's flat, not flat, flat is rather than making tiny changes to a process and trying to observe the difference, is to make larger change so the difference will be more obvious. Very philosophically brilliant, sir. I agree. The way I've always put it is, my rule of engineering is that if you can't fix it, the least you could do is break it. So break it. And then you know what to fix. There's one more picture I want to show you. Also a recommendation. This is from Silo's Garage. If you don't know Silo's Garage, go find him on YouTube. He has a YouTube channel and an Instagram. This was from his Instagram, but there is a video, a YouTube video that goes with this. So he was inspired by the craziness that's been going on, and he made a couple of laps that incorporated the peripheral groove that came from Robin, and he went with triangular grooves. And he put googly eyes on his MAR indicator. So what could be bad? But the true impressive thing here is the very simple, beautiful design of the spherometer. And I love it. So I've been rolling around the spherometer idea, and I did come up with the idea of a linear, I guess they call it a 3-ball spherometer. That's what I heard. But it's adjustable. So if you have a big piece of work, you could make it big. If you have a little piece of work, you can make it little. I like this a lot. So I think this is on my list of things to build. And I think the bar can be made out of anything because the stiffness of steel does not depend on its hardness. So I'm really digging that. So I want to say thank you, sir, Silo's Garage, for this excellent idea. If anybody else has any book recommendations, we're open to that. I would be surprised, Adam, if you did not have a book recommendation for us. Also, I wanted to pass along another trick that I got from Robin, and here's the flat that I've been using. I bought this optical flat off eBay. And the box and the foam in the box were all in terrible shape. So I ripped out the foam, I cleaned it up, and here's the optical flat. And actually you can see some scratches. See the scratches right here? So there were some scratches on one side, and there was a chip on the other side. So I cleaned it up and I used it. You know what I learned? It's fine. So it's a Lapmaster optical flat, and who knows what year it is, but it had this little card in it, and it got so yucky with the foam that I laminated it, and it says that the accuracy is 1/10 of a light band. Any old light band, and it's made out of quartz. So it wasn't too old because it has a regular 5-digit zip code. But there you go. So what Robin taught me was what he called the Kim wipe trick, which I'm going to pass along, and that involves taking your part. I'm not going to actually do this, so because putting a Kim wipe on it, putting your optical flat on it, and then very carefully pulling out the Kim wipe, and that will pull contamination particles out of the interface. And I got to tell you, from messing around on the bench a bunch this week, that works really nicely. So yet another reason to have Kim wipes in your life. If you didn't see my 3D printing video as to why I love Kim wipes, you need Kim wipes. So that's the optical flat I've been using, and Robin's Kim wipe trick. So let's see. I told you about the spherometer. Very excited about that. And a last thing I discovered was that, another use for PFG stones. You may recall that I was talking about the ringability of my discs, right? Well, these are discs numbers 1, 2, 3, and 4. So, almost says another thing to consider at any time the part is rotated on the lap, the surface will change, resulting in convex parts. Limit rotational changes or use rotational changes. Oh. Adam says, sort of related, but when my students are prepping their heat-treated parts for grinding, we find the 3 high spots on the surface and then lap the part on a Renzetti magic sanding plate, which I call a Lapzetti plate. We make sure to push only on the point opposite those 3 high spots. Yep. And then we place the lapped surface on the mag chuck. Yeah, I also made a Lapzetti plate, and it's really good for starting to work on a part on the grinder. Absolutely. It's all related, isn't it? So these are number 1, 2, 3, and 4 of my discs, and I think you will note that they are rung. Okay, so I'll put one pair down. This is number 3 and number 2. Okay, and if I go to, you can't pull them apart. I can't pull them apart. I can slide them apart, but these guys are rung. Now, how did I go from? Remember, I was sort of whining about the ringing. Almost says I have a bottle of Black Max too. I don't know if you're referring to the ringing, but okay, you can't make this stuff up. And no, it's not magnetic. So if I put the opposite sides together, they don't stick. So how did I go from wrestling with ringing to suddenly these guys ringing like champions? Does anybody want to hazard a guess as to how that happened? Anybody? Anybody at all? I know we have a 25-second lag here. But these things are now ringing. Okay. The difference, what is the difference? Brian, everybody is going to think you're a shill. Yeah. I took my lapped surface, okay. I went on my PFG Stones and I gave them like 10 seconds. And they started ringing like nobody's business. Finer grit and practice. Ash Reed says, I'm a little behind, but surely the heat transfer from your hands is negligible compared to the heat generated by the cutting action on the plate itself. That is very possibly true, but stop calling me Shirley. All good questions. I can't wait to get my additional laps made so I can get 1 micron going. Brian says that's how I get my Chinese Joe blocks to ring. I know. So I was pretty excited about the result of that. And what it tells me is that I'm really not very far from achieving my goal of Joe block surfaces. So Black Max is 380. Is that 3M number 380? I actually used Black Max in a product design a while ago. I'll tell you that story. So it was an antenna, of course, because that's what I do when I take off my cape or put on my cape. And there was a small plastic part, and you wound a coil around the part, and then you had to fill a hole with something. So I chose Black Max to fill the hole and then hit it with the accelerator, and you had this antenna ready for the next step in production. So I go to the production floor to check on how things are going with these antennas, because I know they were making like 20 of them or 30 of them for this project, which was a pretty good order. And one of the technicians, actually the senior technician, almost passed out because he did all 20, and then he took the accelerator and started just pumping it on all 20 of these units like a madman, and almost passed out from the solvent. The antennas worked though really well. Adam says, +1 on the wipe pull-out technique. Lens wipes are even better. But aren't you introducing... Are you talking wet lens wipes or the not wet lens wipes? Inquiring minds need to know. Let me know. So what I'm learning is that the little techniques that we're figuring out here is what makes an expert in this business able to do their job. So, K-Bonk, the Lapzetti plate is not this thing. The Lapzetti plate is the 3M 120 grit wet dry sandpaper on a cast iron plate. That's the Lapzetti plate. My homework is now to make them. To make which? I'm getting confused. My homework is to make the... Oh, to make the rest of the lapping plates. So I just bought 5 blanks to make these. So I started the process. I have 5 blanks, and I will crank... Oh, the parallels. Yeah. That ultimately I want to make, if I could generate a 1-inch gauge block quality gauge and have it ring like as good as any, ringing can be done, that would be arriving, I think. Oh, yeah. So Adam says, here's another trick that will blow your mind. Make a spot lap. Make a small ground lap, smaller than your part, and charge it or apply aluminum HVAC tape and then charge that. Then rub the center of your part with a spot lap to reduce the center. Aye, Captain. I like that. So now you're actually starting to be the craftsman, and you're reading your topological results, and then you're going in and doing what's necessary. A popsicle stick charged with diamond works extremely well for fine tuning, says Adam. This is awesome. So can I just point out, can we just take a moment here? Or as I like to say, let's just pop up to 10,000 feet for a second. We're working at the hundreds of nanometers level, or tens of nanometers level, really. Yeah, we're working at tens of nanometers. Can we just take a moment to think about that? It's pretty awesome, especially if your goal not too many years ago was to make something accurate to a few thousandths of an inch, right? Unbelievable. Okay, so we'll throw the floor open for any questions, topics, snide remarks. How do you guys like the new standby setup? You're still doing it. You're calling me Shirley again. And then Adam says, then hit the part on the larger lap just to even out the whole surface and make it continuous. You should be in the car finishing business. In California, you'd clean up. You'd make a mint if you just painted cars and then finished them the way you're talking about. That is awesome. Well, that's this week's achievements. I've got to clean up the shop a little bit and go find my machining center, and I will run the remainder of those 5 plates, and I'll have some more laps to work with. MS Live says some of the watchmakers' polishing and lapping techniques might be worth looking into. A lot of varied techniques for hand lapping, small and weird shapes. Absolutely. And Bob Labs reported that he ordered his Prusa. Thanks for the info. You're welcome. So if you don't know what he's talking about, I released a video this past week on reliable PETG printing on the Prusa Mark III, i3 Mark III. And it was basically a brain dump on everything I learned making these trays, because I've made hundreds of these trays. So I had to get my 3D printing nailed down. And I got questions from Bob Labs, and I got questions from John Grimsmo. Okay, thank you, Adam. He says, not the wet lens wipes. Lol. Thank you. Just to make sure we're talking about the dry lens wipes. Those are they're kind of pink, right? And very thin. Anyway, so I took everything I knew about the PETG printing process on the Prusa, and I put it in a video. And it's pretty complete. I don't think I know anything else about that process that I didn't put in the video. So if you're getting into 3D printing, it's a valid video, even if you're just doing PLA. But specifically, we were addressing the issues of getting to PETG. So that's up on the YouTubes. What else you guys got? Any questions? Anything you want to see next week or in the future? Tell me now, and we'll put it on the list. I'm trying to put something together next week, which should be kind of fun, based on what the feedback we've gotten. And without giving anything away, we're gonna try to have a 2-guest PFG Live. The 1-guest PFG Live we kind of got nailed down, and we could reproduce that. So we're going to try to have a 2-guest PFG Live, and we're going to try to do that next week. Keep your fingers crossed, because it should be a good one. Okay. So any other questions today? Any other topics? We're right on time. I'm very, very proud of you guys. I'm going to have a sip of tea. So, Adam, you built the sort of traditional spherometer, and I think it's pretty traditional for the telescope guys. What do you think of Silo's Garage version of the straight line spherometer? I'm wondering if it's more general use and might be more appealing. Almost says, with your grinder, you really get to decrease the number of charged laps. Absolutely true, Almost, and thank you for your kind words. Brian asks the question that we all want to know. Why does the Flatstones make ringing the cheap Joe blocks work? Because PFG stones make flat things flatter. That's why. And people say, well, if you buy gauge blocks, you get a special stone from Starrett. It's a special stone. Don't use anything else. Really? Because I make stones that I guarantee are as good as anything you're going to get in the box from Starrett. I use them on my gauge blocks. One of the things I want to do is measure the material removal when you do that, and I think it's very negligible. Compare dry lapping with charged embedded grit to wet lapping with slurry would be interesting. It would be, wouldn't it? There's so much to learn here, but that's an interesting. I'm going to take that as homework. I don't know if I'll have any answers for you. Dry versus wet is essentially the question. I think wet has an advantage of getting rid of the effluent, getting rid of the cut material, but we'll see. All right, guys, it's top of the hour. Thank you for being here. I appreciate it. This was fun. I love learning new stuff, and boy, howdy, this week was learning new stuff. So we'll see you guys next week. Again, I'm trying to put together a 2-guest version. We'll keep you posted on all the usual socials. And if you have anything you want to see covered for next week, please drop me a DM, and we'll try to get that to happen. Thank you, Adam. We're getting closer to nano precision for the masses. You betcha. Thanks, Kevin. Thanks for showing up. Bob Labs, take care. MS Live, thank you for your kind words. And with that, have an awesome rest of your weekend. Take care, guys.